Hello. All right. Hi, everyone. Welcome back to another lecture in mathematical methods. As you can see, I now have my calculator with me as well because we're going to start getting into a lot of number crunching soon. Maybe not in this lecture, but from the next lecture onwards, a lot of number crunching. Which also maybe gives you the hint that today's lecture is a lot more just me telling you stuff instead of teaching it. There's no other way to go about it. I usually do prefer to make you understand stuff, but here the bottom line is you have to know the stuff. You just have to know how to use them. Can't get any. It's that simple. All right. So with that out of the way, let's get started. Okay. So today we're looking at the stats for continuous random variables. So what are stats? Your mean, median, mode, average, all that sort of stuff. Okay, so let's start off with the mean. Okay, as usual, the mean you represent it with the mu. You already know that. All right, that's the expected value, the average outcome. Oh, sorry, the average value or the expected outcome. Okay, and for continuous random variables, it is defined like this. Okay, so an integral, as we've been doing, all right, from a to b, which is a being the start point and b being the end point. In fact, I would just describe this at the start. F of x is your probability distribution functions from a to b. Okay, a being your start point, b being your end point. Okay, of the entire function. Or not the entire function, but the specified range. Okay, so a to b, x times f of x dx. Not f of x dx, x times f of x dx. Okay, all right. That is how to calculate your mean. Simple formula, all right. Do it by hand or put it into the calculator. Very straightforward process. Okay, next, the median. Okay, now typically you would think of the median as you order the numbers, find the middle one. All right, that is the definition. It's the middle value. But in terms of in terms of continuous random variables, it's a bit hard to find. All right, but the way you find the median is you have an integral from the start point to m. Okay, and a bit like what we did with discrete random variables, we found where the value becomes 0.5. Okay, we do the same here. We go what what value here, which would be m or our median, what value here do we put so that when we integrate from a to m with respect to x, we get 0.5. Okay, you know how we were doing in discrete random variables, we add up the probabilities till we get 0.5. We're basically doing that. We're finding a range to which the probability equals 0.5. Okay, this one is a bit more complicated. Okay, sometimes you have to do it, most of the time you have to do it by hand, unless you have a Casio. I think on the Casio you can do it by the calculator. I don't think you can do that on the TI either. All right, so you do that, do it by hand. If you can find a way on the calculator, even better. But typically, when you're supposed to find the median, they ask you to use algebra anyway. So it's you kind of have to be able to know how to do it by hand. But the good thing is you don't have to learn anything new. It's just integrals. Okay, you've already been doing this. Hopefully, you've already been practicing this. Okay, moving on. Okay, we did mean, we did median. Now we do the mode. Okay, so mode being the highest occurring value, all right, we already know that definition. So if you have a curve, what's the highest occurring value? Obviously the max. Okay, so what you do is you find the max of f of x in the given range. Okay, you find the maximum value in the given range. Use normal differential calculus. Nothing too complicated. All right. So the variance or the standard deviation, all right? Why do I write them together? Because we know that the two of them are linked by simply a square, okay? So the variance is the square of standard deviation, all right? So if we can find one, we can just find the other. So what I'm going to do is I'm just going to show you how to get variance, okay? And then you can square root it to get the standard deviation. You can do just put that in a calculator or whatever you want. But here's the simple formula, okay? So the variance, or sigma squared, is equal to a to b, from start to finish, of x squared f of x dx take mu. So notice how it's very similar to that formula for the variance and standard deviation for discrete random variables as well. Okay, we had a sigma and we had x squared and we had mu's and stuff. It's very, very similar. Okay, and back then we had two formulas. Same thing here, we have two formulas. Okay, x take mu whole squared, f of x dx. Okay, simple stuff. All right, nothing that complicated. Again, put that into a calculator or do it by hand. It's literally just the formula, square rooted to get the standard deviation. Now, I think I've said it a lot, but this is it. All right, this is all you need to know for continuous random variables. Okay, you may not even need to understand what is going on. Obviously, it is much more better too, but you don't need to. If you can just get the calculus here done, you can get the integration, you can get some of the differential calculus done, you are in very, very safe hands, aren't you? So just do that and you'll be completely fine. That is my promise. Just learn the formulas and know how to use them as all that's required. Actually, don't even learn them. Just put them on your cheat sheet properly, but know how to use them, okay? These are free marks. Whenever something like this comes up, do not waste it, okay? So that's all for this lecture. Good luck.